Welcome to The Explainer. I am absolutely thrilled you're here today because we are tackling one of the most notoriously tricky areas in the Cambridge computer science syllabus. Think of me as your personal climate scientist for exams. You know how a climate scientist reads the early warning signs, the shifts in atmospheric pressure to predict and avoid a massive storm? Well, that is exactly what we are doing today. We are reading the explicit warning signs from Cambridge examiners to help you avoid the common pitfalls that absolutely sink grades. We're looking at the Ultimate Examiner's Playbook for mastering processor types and core numbers, specifically focusing on the Cambridge 9618 AS and A-level computer science exam. But listen, whether you're studying for the 0417, 0478, 0983, 0984, 2210, or even looking back at classic 9713 past papers, the strategy we are about to uncover applies across the board. Let me paint a picture of a real past paper scenario for you. We constantly see two types of students tackle these performance calculation questions. First, we have Alex. Now, Alex overloads his paper with raw computer science facts. He memorizes every single technical detail about clock speeds, RISC versus CISC architectures, and cache memory, but he provides zero actual analysis of the scenario. Then we have Sam. Sam is constantly racing against the clock. He rushes through the prompt, completely misses the command word requirements, and just word vomits generic knowledge. Both Alex and Sam leave the exam hall feeling super confident, and both end up with a massive storm of red ink on their papers. Today, we're going to transform those red marks into green check marks. Here is our masterclass agenda. We're going to start by unpacking the core trap, move right into the top explicit warnings directly from the examiners, build a bulletproof procedural framework, master critical comparative analysis, and finally, reveal the ultimate safety net, the method mark strategy. This is a direct look into the assessment framework. Section 1. The core trap. Okay, let's build our understanding of where students first go completely wrong. When you sit down and look at a question about factors affecting computer performance, specifically regarding processor type and the number of cores, there is a massive conceptual hurdle that immediately trips up even the absolute best candidates. It all comes down to how you perceive the assessment objectives. These objectives target very distinct cognitive domains, right? Knowledge, understanding, application, and analysis. The trap, the core trap, is thinking that just spitting out knowledge is enough. This brings us to the ultimate battle, superficial breadth versus analytical depth. Remember our student Alex? Alex relies entirely on superficial breadth. He will write an entire page listing what a core is, what an ALU is, and maybe throw in some trivia about pipelining. But he completely fails to analyze why a quad-core processor might not actually be 4 times faster than a single-core processor in the specific application given in the prompt. He completely ignores Amdahl's law. Academic benchmarks for the 9618 syllabus require logical, structured reasoning. The assessment framework heavily prioritizes analytical depth. They want to see you break down the causal relationships. Does the software actually support parallel processing? Are there bottlenecks in the bus width? You need deep analysis, not just a broad list of vocabulary words. This is absolutely crucial, guys. A direct quote from the principal examiner reports really underscores this. Candidates referencing cross-topic connections achieve significantly higher marks. The theoretical architecture of this topic demands precise definitions, yes, for sure, but it absolutely requires integration with other syllabus areas. If you are discussing processor cores, you should immediately be making connections to operating system scheduling or parallel processing limitations from your algorithm design modules. Examiners actively reward you for showing that you understand how the whole computer system works together, not just isolated components. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Section 2. Top Examiner Warnings. So we've looked at the theoretical traps, but now we need to look at the practical application. What are the specific repeated errors that Cambridge principal examiners are practically begging students to stop making? Let's dramatically unpack these 3 fatal traps that consistently sink grades on multi-core processor questions. Mistake number 1, using the wrong formula or algorithm for the context. If you are asked to calculate performance improvements, you can't just apply a parallelization formula blindly if the scenario describes a strictly sequential single-threaded process. Mistake number 2, forgetting boundary conditions and edge cases. When discussing multiple cores, students almost always forget the overhead of intercore communication. An edge case might be a task so computationally small that the time taken to divide it among the cores actually exceeds the time it would take to just process it on a single core. Or what about thermal throttling? You pack too many cores into a small device, it overheats, and performance actually drops. And mistake number 3, which brings us back to our rushing student Sam. Sam's answers are not specific to the question's context. Sam completely misses the command word requirements, he sees the word processor and just dumps a pre-memorized paragraph onto the page. Which leads us to this absolute golden rule. Context is king. Generic answers fail. Period. Apply your knowledge strictly to the prompt's scenario. Sam completely ignored that the prompt asked about a processor for a mobile embedded device, which has massive power and thermal limitations. If the question mentions a weather forecasting supercomputer, you need to talk about parallel processing of massive data arrays. If it mentions a basic smart home thermostat, you need to talk about energy efficiency and explain why a multi-core processor might be a massive, expensive overkill. If you don't link your technical knowledge directly to the scenario, you are literally throwing away application marks.
Section 3. The procedural framework.
All right, so how do we guarantee we hit those top marks? We are shifting right now from what not to do into the exact step-by-step procedural framework required to build a winning algorithmic answer. Top students don't just write, they architect the responses. Let's walk through this 4-step algorithmic thinking pipeline that examiners actively look for when grading practical application skills. Step 1 is step-by-step decomposition. Before you write a single word, break the problem down. What is the processor actually being asked to do? Step 2 is data structure selection. How is the data moving through the cache and the registers? Step 3 is efficient implementation, and in the context of theory questions, this means efficient structuring of your argument using the PEEL framework, point, evidence, explanation, link. You make your point about the processor core, you provide evidence directly from the scenario, you explain the technical mechanics of why it matters, and finally, you link it back to the question's core objective. And step 4 is rigorous testing. In an exam, testing means rereading your answer to ensure it directly addresses the command word. Did they say describe, evaluate, or analyze? Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to Ace the Exams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
And as you apply that PEEL framework, you absolutely must utilize highly tuned data interpretation skills. This is where we run our first interactive workshop challenge right now. Challenge 1 is the data scan. Imagine a complex data chart on your screen right now, showing execution times for a dual-core versus an octa-core processor. I want you to imagine a 60-second timer. You need to quickly extract the relevant data from these representations. Usually you'll see a trend where the octa-core dominates parallel tasks, but actually lags slightly on sequential tasks due to the overhead of managing those cores. You have to perform the necessary calculations, like determining execution time based on clock speed, and then draw evidence-based conclusions. Are there bottlenecks? Is the L1 cache hit rate too low? Challenge 2 is finding the flaw. If a sample paragraph says, the octa-core is always faster because it has more cores, you need to spot immediately why that loses marks. The flaw is that it ignores sequential bottlenecks. Your final written conclusion must be based strictly on the math and the data provided.
Section 4, critical comparative analysis. This section right here is where we secure those elusive, top-tier higher-order marks. Literally anyone can identify a basic fact, but evaluation and comparison, that is what separates the A-star students from the rest of the pack. We use the deconstruct, solve, evaluate loop. You deconstruct the given information, break it into logical, manageable steps. You solve it systematically using the knowledge you have, and then you evaluate. Which brings us to challenge 3, speed writing. Imagine you have a 30-second timer to write one perfect PEEL paragraph evaluating 2 different processors, checking for reasonableness, and making justified recommendations. How do you do it?
You do it by making sure comparative analysis is your secret weapon. True comparative analysis requires identifying both similarities and differences. But listen to me carefully. It's how you write them that gets the mark. You must support your similarities with actual evidence from the data table. And for differences, you must use comparative connectives. I'm talking about words like whereas, conversely, in contrast to, and however. Do not just list the features of processor A in one paragraph and then list the features of processor B in the next. That is not an analysis. You need to compare them directly in the exact same sentence. For example, processor A has a larger L1 cache, which significantly reduces memory latency for sequential tasks, whereas processor B relies on multiple independent cores, which is superior for multithreading. Therefore, relative to the video rendering context given, processor B is the more appropriate choice. Boom. That is how you draw powerful conclusions about relative importance and secure full marks.
Section 5, the method mark strategy. So what happens when you follow all these steps? You deconstruct the prompt perfectly, you select your framework, but the calculation on the paper is just incredibly difficult and you start to panic. What is your ultimate exam survival tactic? I need you to commit this examiner alert to memory right now. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Let's be real. The process is often just as valuable to the examiner as the final output. If you are asked to calculate the performance increase of moving from a 2 GHz single core to a 1.5 GHz quad core with a 20% parallelization overhead, and you mess up the final division, if you wrote down the correct formula, and if you substituted the correct numbers on the page, the examiner actually wants to give you marks for your method.
Show your working. Method marks literally save grades. Execute your answers with clear notation. Present them with the correct Cambridge terminology. This is your ultimate safety net. It preserves your mark potential even when the math gets messy. Remember, the complete system we've built today: command word decoding, PALL framework application, and strict time management matrix. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
So I leave you with this final provocative thought. Are you ready to stop memorizing raw facts like Alex? Stop rushing blindly like Sam and start deeply deconstructing your next past paper using the deconstruct, solve, evaluate method? Take these strategies, apply them to your next mock exam, and watch how quickly your mark potential skyrockets. I'll see you in the next explainer. Keep analyzing.